my name is Francis, and I'm not an expert in supercomputer at all. But I got this set of slides from National Supercomputer Center, and I felt that it was very important to share what's happening in Singapore. So our goal for the National Supercomputer Center is to democratize it, to let people have access to it, and not just say only for these researchers and only for that researchers. So in actual fact, working with SingaRAD, with a single sign-on, we actually allow a lot of students to quickly get online to use the supercomputer. So it's a working between the NRAN and the National Supercomputer Center. They were very happy rather than saying, oh, okay, if you want to log in, you must apply for account and everything. In actual fact, accounts are automatically set up. Okay. The minute you log in, your account's there. As long as you're a student from the universities, the partners, got an account down there. So it opens up a whole new field for students to use it. The other thing is also to get industry. It's not only for academics. In actual fact, more and more industries are coming in, and more agencies are coming in. Recently, I was helping an agency transferring data from Australia back up to Singapore for the climate simulation part of it. So it's fun. So coming to the funding, it's funded by National Research Foundation, same funding body as for the NRAN as well. It's a national level resource. We know that the universities have their own resources, and that's fine. So you think about it, is the NSCC is a tier 1 supercomputer. Then the universities are all those are tier 2, the departments are tier 3s. Okay. The high-speed network, and that is working together with SingaRAD to provide high-speed network among the universities and also international. Research is not conducted just within the country. It's international. International collaboration is very, very important. It's Singapore's first national petascale facility. It's just LIMPAC, that's all. It's very expensive. We had the Aspire 1 with us, and then we built up AI platform because they need a lot more GPUs. Then with a high throughput computing, so that there are many very fast short jobs handle it there. While the Aspire 1 is for bigger jobs, which may take a little bit more time. But if your jobs are not that big, come on to this. So there are different types of users that we have on that. Aspire 2A is a new system that came up, just came up recently, and it's big, but not as big as high SC, but it's big, quite big. And the part of the reason is after Aspire 1, we found the utilization so high that we need to quickly upgrade, and the government support us to upgrade. So connecting Singapore research with the world, they rely on SingaRAD. So it's no longer the network is one part and the HPC is another part. They are all integrated together. Growing local HPC community and international collaboration. So here there's H supercomputing to Singapore hospitals. Okay. I myself take students for competition, or students cluster competition that's held in ISC in Hamburg, as well as in supercomputing in the US. I've been taking them since 2016, but now I'm retiring from them. I handed it over to someone else. And it actually shows we are actually on the top. We won the competition in 2017 at SC International Competition for not only the highest impact, but overall performance. And then Tsinghua University is also very active participants. We actually bring our gear over there, set it up within the power limit and run it. What I like about the competition is that it puts students to learn and think on their feet. Number two, they meet other students who will eventually be their peers. And they meet mentors from other places, not only me, and other people. And they inspire them. In actual fact, some of the students has gone on and followed on to HPC. You need them to interact. Well, we have ultra high speed, and I think you can see some of this, the similar, Andrew. And we really have high speed to Japan. I think I won't talk about the big networks that backbone networks that have, and we need it. Transferring from Gaudi, Australia, up to Singapore, we are pushing it about 8 gigs. And if you've gone for a commercial network, it's with 10 to 20 to 30 times slower. And we were copying about 4.5 petabytes of data. It's not your 1 terabyte, gigabytes, it's petabytes of data. So global links is very important. Okay, NSCC is one of our major partners that use the links quite extensively. This was just been set up. Now, HPC are just not working alone by themselves. They're forming alliances. We know that in our region, for us to have extra scale, it's no way Singapore can do that. So what we're thinking is, why don't we have an alliance of supercomputer centers together, working together and build up maybe a scale big enough to share jobs around? But you need high-speed links. If you don't have high-speed links, if it takes so long to just transfer across, then it's no use. So that's why we are pushing very hard for the high-speed links. So we have Corsi, CSC, Europe, Riken in Japan, TISC, San Diego Supercomputing, Poland, NCI, Australia, Chaos, I think, no, okay, there's Singapore. So if you look at it, we are the not so big guys. We are not the US or the big European fundings, but let's see how we can do things together to help our researchers. So that's the alliances. It was just formed at SCA 23. We have joint calls, Japan, Singapore calls for Fugaku projects. So you see how we are working with. We may not have this super powerful Japanese computer, but I have to thank our Japanese friends for allowing us to run some projects on their system. But we are very clear. I was reviewing the projects that we shortlisted to run. It must be something big that can push the supercomputer, Fugaku supercomputer. Then we push it there. Otherwise, the smaller jobs will just trigger. So it's a grant where we actually look specifically at the project itself, the project's technical part of it, and whether it really can demonstrate how. And you think about it, it's really opened the eyes of some of the researchers. Yeah. We run the SCA 2023 recently, and it's been running for a number of years, and finally it came back as in person. For the past 3 years, it was all virtual. And this time around, we co-organized it with HPC Asia academic program, and we brought in 1,000 people to the convention center. The sponsors were very happy because they got so many people they talked to. We are very happy because now not only academics talking to academics only, academics talking to practitioners. So there's a good partnership going on. So international collaboration, there is a number of MOU signed between NCI Australia, and NCC, MOU. In actual fact, NCI Australia is a very, very close partner. Okay. And next year, SCA 2024 will be in Australia. They're going to host SCA 2024. And Andrew will be one of the major players down there. That's all I have. I thought I'd just give you a glimpse of what's our mission. You know, what's pushing us to do it. We want to open it up to as many people as can. We cannot exclude industry because industry plays an important role. We have to help the industry to get their technical skills up, you know, and that builds the country. That's all I have. Thank you.
Thank you, Francis. So with this, we conclude the first session. So I think the lunch is waiting for us. And thereafter, we'll have the two distinguished guests. Yeah. I suppose already there's not emphasis.
Supercomputing. Should NREN go ahead with establishing a supercomputing center, or should they only facilitate network support? Another question, that is actually, is there any success case of user being in one country and the supercomputer located in another country? You were mentioning, but is there any success case, or is there any, can you share any experience using such a model? Only issue is speed or network. That's the only chapter, right?
The prime examples of actually doing this was work we did a couple of years ago, which pending cloud 2.0, where we connected 5 supercomputer centers around the world on an extended band network, and basically build a highly distributed supercomputer facility, which was a really terrific processing around it. So there's a number of examples of research in pending cloud 2.0 and we've got a background research about it.
Yeah, so I can give you some examples, success examples in the afternoon. I borrowed the slides from Gonzaga-san. So it's as Francis already told, Asian collaboration is already going on. So it's many existing good examples in this knowledge.
I hope that will open up, but it depends on the Japanese to other countries as well. So that it's really, people will be surprised when they use it. but it must be big enough problem. Then you go on to it. That's why we only selected 5 each round. And it goes through a tough process. It's not only reviewers from Singapore, reviewers from Fugaku, Japan as well. We review it, we rank it, and we see how that match out. So I'm hoping that maybe what was it? Sorry, I can't pronounce. He's in charge of Riken, and maybe we can open that up a little bit. But it may need some MOU or some sort, and not just simply open up to the rest of the world, to sort that out. But at least we have restarted opening, showed how to open it up. So I think there's opportunity to open it up. Yeah. I always think about you all. You know that I always think about you all, okay? Yes.
Yes, thank you for that very comprehensive, wonderful presentation. I represent HPC Nepal myself as a non-profit organization. I think I met you earlier if we were in the same supercomputing center conferences. I visited a few of them, and I was quite impressed with the student cluster competition that used to happen there. So one of my model was to bring that to Nepal, and somehow I've been in collaboration. I've signed an agreement, but we get to go into that journey ahead. But having said that, with the HPC, the whole mission was to build an infrastructure and then provide those kind of bring up the workforce that's needed for building a super infrastructure and the training models itself. So you said like you have so many training models and sort of things. Is that a possibility where Nepal could also be participating in those training programs and bringing back those kind of expertise here? And because what Nepal needs particularly right now is the awareness, the HPC awareness, right from the school level, you should call it to a PhD level, whatever it is. So we're trying to do that outreach programs right now. We do not have our own infrastructure, but yes, possible people are willing to help, willing to guide. And I think it would be a great opportunity, a possibility where we could explore further on in this event. Thank you.
Actually, part of the reason why Raja and me organizing this session is actually to open that out and help us more. And some training, you don't need any resources because resources are provided to you through the cloud. There's some competition called HPC AI, and Thailand's teams have really risen to the top already. You all recently won it, right? Yeah. So and that's a great training. And you see, it's doing these little things and participating in it. And then the seniors actually help the juniors. The faculties are no use already after that. It's the seniors helping out the juniors and passing on their learning. And some of the really good seniors, they play around with it so much. They know so much more. They have all the time to play. And that's their passion. That's where it comes out. That's what I see in my students that get more competition. They build that passion, and then after that they continue on. And if you are good at it, you get very good pay. You are really wanted by the customer. And in your case, let me know. One of the things that just now, that's why I asked HiSC the questions, because they ran the EU ASEAN education. And that was very good education. You have people from Europe, Japan coming down. They are expert to teach, and you have your hands on to it. Okay, sometimes you need that. Okay, and so the next one will be in Indonesia. Okay, and let's see whether it may not open up to everyone. But let's see whether they can open a few seats for the other countries outside ASEAN. although it's EU ASEAN, let's see whether that can happen. I can't guarantee it, but we try our very best. So I hope I answer your questions. So this is where we come together and see how we can help each other.
All right, thank you, Francis. So we are already 20 minutes behind the lunch. So we will have more discussions on the after on sessions as well. We have a very important speakers are left. So we will get information about the species in Japan and in Australia as well. So let's go for lunch and thereafter continue this discussions and how we can have greater availability to the especially resources for NDCs and those countries has low resource settings. Thank you.
Right in. Sure. On the East Coast, as I mentioned, NCI with our Guardi system, and on the West Coast, Aussie, located in Perth, has their Sotonic system. Both centres provide supercomputing, cloud, data analytics, and most importantly, community outreach and training. Some of the things that make NCI unique are our infrastructure. We closely bring together our high performance computing Guardi, our research cloud, Niren, which I manage, and our high performance storage, which we call G-Data or global data, into a single integrated research environment. This allows us to offer high performance computing, cloud computing, data services, virtual research environments, data storage, visualization, and HPC optimization. Our storage facility is over 100 petabytes of cluster, which is our high performance file system, connected to our HPC system, combined with around 30 petabytes of Ceph, which we use for object storage and volume storage capability within our Niren cloud. Guardi is a 155,000 CPU cores with 567 terabytes of memory and 640 GPUs. It's comprised of 3,074 nodes, each containing two 24-core Intel Xeon Scalable custom event link processors, 192 gigs of memory. This slide is slightly outdated. Over the last 2 weeks, we've also added an additional 8 racks of Intel Sapphire Rapids, their latest CPU technology. 50 nodes each offer 1.5 terabytes of Intel Optane system memory. 160 nodes contain 4 NVIDIA V100 GPUs and 2 24-core Intel Scalable Cascade Lake processors. Linking the storage systems and Guardi together is a Mellanox technology 200 gigabyte per second InfiniBand interconnect configured in the Dragonfly Fly Plus topology. The storage systems are NetApp enterprise class storage arrays linked together in a DDN parallel file system. We use Altair's PBS Pro as our scheduling system, and Guardi did use the latest version of CentOS 8 until they discontinued support, and we've migrated over to using Rocky Linux instead, which is CentOS compatible. I'd also like to introduce Aussie's newest supercomputer, Sotonics, which is a Cray EX system with over 50 petaflops of raw compute power, 200,000 AMD compute cores, 750 AMD GPUs, 548 terabytes of memory, and it is 10 times more efficient than its predecessor system. That's a photo of Sotonics. The small animal you can see on the left-hand side is a quokka, which is a native animal which exists on an island called Rottnest Island. For those of you who attended the Supercomputing Asia event 2 weeks ago, the quokka is the go-to takeaway that everyone wants. So NCI has koalas, our partners at Aussie have quokkas. I'd like to tell you about my system, which is called Niren. Niren is from the indigenous Wiradjuri language and means the edge. It's an OpenStack cloud covering 22 racks distributed across 2 data centers with 1,440 Intel Core cores, 42,000 Intel Sandy Bridge cores, 200 terabytes of memory. We've got 4 of the Optane nodes with 3.6 terabytes of memory each, 80 K80 GPUs, 6 petabytes of Ceph operational disk storage, which we use for volume, Ceph FS, and S3 object storage. And we have an additional 12.5 petabytes of Ceph storage, which we share with our HPC group. My cloud's connected using a combination of 100 gig and 56 gig Ethernet. And one of the kind of unique capabilities is we run it as a dispatchable compute environment. So we're able to power up and power down nodes based on demand for energy saving and efficiency. So typically we'll see the load start to pick up in the morning. We'll heat up the nodes and get them ready to roll. At the end of the day, when we start seeing load drop, we like migrate as much of the workload onto the minimum number of nodes possible and then power them down. Our sister facility, Pawsey, has their Nimbus cloud, which is also OpenStack based. It's 3,700 AMD cores, 58 terabytes of RAM with 9 petabytes of volume storage, also supported by SAB. It contains 12 NVIDIA V100 CPUs and utilizes primarily 100 gig Ethernet networking. Like most supercomputer centers around the world, during COVID-19, we provided accelerated access initiatives. These were basically provided for free to researchers in Australia and around the world for processing and analysing genetic sequences, performing mathematical modelling of the vector stages and transmission and containment, performing computational prediction of protein structures associated with COVID-19 virus and associated biomolecular modelling. Also modelling the economic impacts of COVID-19 on global as a global pandemic. Performing population mapping and demographics, working on biosecurity, and also performing epidemiological modelling of the COVID-19 virus. We've just commenced a new project called Prospect, which is a national genomics project. This is one of our major commercial focus. Been funded $158 million by the Australian government. The aim of the project is to take 20,000 cancer patients who have a very bleak outlook. We're going to be and are currently working on connecting the commercial pathology laboratories to provide the sequencing data. We're using the Globus file transfer system, which provides commercial support, which is important for our industry partners. NCI will be providing data storage, compute, security, and our genomics expertise. And this brings our big pharmaceutical companies and national data analytics companies into NCI for the first time. So we're combining multiple centres of expertise under a single umbrella. Some of the challenges with industry involvement are that we need to increase our data security and encryption both in flight, over the network, and at rest. This is based on our experience with the National Centre for Indigenous Genomics, and the poll you can see on the right was donated to us by an Indigenous community, trusted us to hold their genomic data in a highly secure manner with an informed consent system, which we go back to the community to ask every time we want to access that data. This has taught us how to maintain privacy while supporting trials of new drugs, treatment options and techniques. And we're challenged, the challenge is balancing research, which has been NCI's traditional focus, with an increasing commercial focus. NCI holds around 15 petabytes of reference data collections. These are research data sets brought together at NCI and organised for both high performance computing and high performance data analysis, as well as being made available more broadly to the Australian and global research communities. Our data collection hosting is Australia's largest collection of climate, weather, Earth systems, environment, satellite, and geophysical research data sets. One of the unique capabilities we've introduced in the last year is something called Australian Research Environments, or ARE. It's based on the Open On Demand system by the Ohio Supercomputer. It provides an intuitive, innovative, and interactive interface for remote computing resources, which allows anyone with a web browser to access our facility This supports a wide range of client needs and can utilize compute resources. And users are able to use remote computing without installing tools or having to do any tool installation on their local laptop. They can just basically click on a website, log in, and they have a range of pre-packaged applications and services based around Jupyter notebooks and those. We provide a graphical user interface. We use Globus for data transfers, and our technology preview opened in July 2021 with 1,000 users replacing our existing virtual desktop interface. We've since migrated to a fully integrated platform for ARE at the end of 2020. Australia is quite a harsh country. We need to look at things like protecting lives and property from extreme bushfire events, which are quite prevalent. And University of New South Wales researchers use Guardi to discover unknown modes of fire propagation. The simulations, which were derived from existing data based on the 2003 Canberra bushfires, which reached around to nearly 15 metres away from my home, include numerical weather prediction models and computational fluid dynamics. This research into bushfire behaviour may aid communities and firefighters during catastrophic fire conditions. And the research could not have been completed within a reasonable time frame without the Guardi supercomputer. So the facilities and support at NCI are absolutely critical for the core research of our group, which was a quote from Professor Jason Sharples from the University of New South Wales, Canberra campus. We also enable time-critical research to develop a COVID-19 vaccine. Guardi supports 4 Australian research groups investigating COVID-19. This is after our Access initiative. The researchers were chosen from a large pool, and allocation were based on merit. For example, some researchers simulate protein structures and human cell receptors. And NCI was able to provide 40 million compute hours at very short notice. And that 40 million compute hours is equivalent to 4,000 years of computation on traditional laptops or desktop PCs. And in support of that, quote from Professor Megan Mara from the Australian National University, NCI's new Guardi supercomputer is the only supercomputer in the Southern Hemisphere powerful enough to do these simulations. We also support looking at evolving climate and climate change, both nationally and internationally. We're home to the CMIP6 collection, which is a multi-petabyte climate modelling resource used by the Intergovernment Panel on Climate Change, the IPCC, which you would have heard has made the predictions in terms of the global temperature rise. CMIP6 dataset informs researchers from more than a dozen research organisations across Australia. Some of the data is relevant globally, connecting NCI to the global research community. And NCI is the only facility of its kind in Australia that can support this sort of intensive data analysis and simulation that CMIP6 requires. CMIP6 is the most comprehensive suite of climate science experiments ever conceived. We hammer the NCI peak system Guardi, and it's a credit to Australia. And that's from Dr. Simon Marsfield from CSIRO. One of the areas that I've been involved with is processing genomic data sets. Our Garvan Institute of Medical Research, the National Centre for Institutional Genomics, and others use NCI for processing, storing, and analysing human genomes. Around 4,000 autonomous genomic samples of healthy seniors are processed and stored at NCI as part of the Medical Genome Reference Bank. And NCI is working with a consortium of national research institutes, including Omico, Garvan, Children's Cancer Institute, and Roche Australia, to establish a cancer treatment program. A quote from Omico that they are delighted to work with NCI on the largest cancer precision oncology program. This partnership will change treatment options for more than 20,000 Australians battling incurable cancers. Some of the key metrics which I can't read. But you can see we've had a significant ongoing growth in the use of our facility from our previous supercomputer, Rygen, in 2021 up to 2022. We've started to flatten out on that, but we would expect to see another increase based on the installation of our new Sapphire Rapids capability in the last couple of weeks. So some of our key metrics, 135 sessions, 3 core partners, 21K learning time in minutes, 219 attendee organisations, 7,762 registrations, 4,561 attendees, and 34 attending countries and regions. Our reach is global, and we collaborate with a number of other supercomputer centres around the world. Some of these metrics describe the recent HPC AI training program that was conducted and run by my colleague, Jinbo Wang. And I was honoured to actually present the winners with their certificates at Supercomputing Asia 2 weeks ago. As many of you have mentioned and asked, training for the next generation of HPC specialists needs to start early, and programs like this are available around the world and will provide your students with access to key HPC facilities in Finland, Thailand, Australia, Japan, and of course with our NSCC colleagues. So this was a fit for purpose to teach strategies and learning journeys. My colleague loves dogs, so we compare a puppy in training to a guide dog in training, a working guide dog to an autism assistant support dog. So we need to train the puppies to become the support dogs of the future. And the concept of a learning journey with a different scope of context. We look at multilinear regression, which is the entry point for beginners. This is in AI and machine learning. Decision trees, neural networks, extreme gradient boosting, random forest, and convolutional neural networking. The HPC AI competition 22 supported 25 projects, 100 participants, 12 countries, and involved a lot of learning. And it was a big achievement for every team. Some of the quotes we have, this is our first time that our team, comprising 4 sophomores and 2 juniors, participated in this kind of international competition. During training, we learned the fundamentals and diversity and the variety of high performance computing. Our team really enjoyed these challenges. The development of HPC AI platform capabilities is a key strategic objective of NCI Australia. Events such as the Asia Pacific event, APAC HPC AI student competition constitute timely milestones that facilitate the build out of new capabilities of NCI's Guardi, HPC and Neural Cloud infrastructures. As Francis also mentioned, the teams are comprised of juniors and seniors. The seniors teach the juniors and evolve them to the next level of leadership as they graduate from university. So it's an ongoing and evolving learning process for these students. Education is rewarding in many ways. However, you can have catastrophic things go wrong when you change one line of code. We also see it as providing the step up for people to actually get access to the facilities. And by doing that, kittens can become pirates. So as a community, both as HPC and as an APAN community, together we can change the world. That concludes this presentation, but I'd like to just do a brief advertisement for our upcoming Supercomputing Asia 24 that our colleagues in Singapore originated and have been hosting. We're privileged to actually bring Supercomputing Asia 2024 Australia. No audio, but it will be held at the in Sydney. You can see some of our unique wildlife. We'll be bringing HPC, cloud computing, and AI together. Looking at with a focus on data science, cloud computing, population modeling, and supporting the global high performance computing. And as I mentioned for the first time, this event will be held outside of Singapore. And we invite you all to come down to Australia to participate in SCA 2024. So with that, I'll open up for questions. Thank you very much for your time today. So ARNet is our National Research and Education Network. We have 4 100 gig network links from ARNet. ARNet itself provides a traverse path. So there are 2 paths going across the continent and then an undersea path, which goes around the bottom of Australia. This avoids a cable cut or as was experienced by our New Zealand colleagues about a month ago, where they had a major cyclone hit and all of the fibres were connected with bridges, which were suddenly washed away. So as a very harsh environment, it can often take days to get a fibre team out to actually fix or splice one of those fibres. We're also privileged to have around 800 gigs of external capability provided on a number of cable systems. We connect on the East Coast via 2 paths to Hawaii, a path to Guam, and on the West Coast, a path directly after NSCC in Singapore, which provides us access to data sets in Europe as well as data sets. The majority of the Australian population is located on a very narrow margin on the East Coast. So the loop, we don't loop all the way around, but it's kind of more of a reverse J. Yes, with 100 gig dedicated connection. Yeah, pretty much so, yeah. Yeah, we are absolutely dependent on ARNet to achieve our goals. You know, having a supercomputer in isolation is a completely useless thing. As an example, we are continuously streaming the data from the Sentinel satellite system operated by the European Space Agency. So it's absolute, and this is used critically in an hour-by-hour basis in natural disaster management. So when we have a bushfire, they can move remarkably fast. We dedicate large components of our cloud systems to run bushfire modelling models, which are then used to drive the national alert system to tell people when they need to evacuate. But as I said, it's come uncomfortably close to our national capital. I can see the flames and smell smoke from my backyard. Yes. And those then are used to do SMS broadcasting alerts to advise people to evacuate, and to also drive our national information centre through our national broadcaster, the Australian Broadcasting Corporation, who still run AN services to actually make the reach to some of the remoter communities that may not be served by FM services. Some of the things about the bushfires were though that some of the first things to get burned down were the telecom towers. So having that AM radio facility there, able to provide wireless, is absolutely essential. That's two great questions. First of all, we're as part of the Asian HPC AI training initiative, we're making our supercomputer facility available for researchers around Asia and students. As I mentioned, the juniors, seniors teach the juniors, and that's kind of an ongoing process. In terms of containers, we're part of a national initiative called ARCOS, Australia Container Orchestration Registration System. We use containers extensively as part of our cloud service. And wearing my other hat as the co-chair of the Asia Pacific Research Platform, containers are an integral part of our Kubernetes-based infrastructure that will be made available on a no-cost basis to researchers around Asia Pacific. This is a combined initiative between KISTI in Korea, NCI in Australia, and we've dedicated one rack of our cloud service to support those initiatives, including around 20 K80 GPUs. So they're not the highest end, but they certainly provide the same sort of environment for students to learn on and then migrate and be able to fully utilize our Gaudi high performance computing system. It's really key to provide that gateway. Just landing someone on an HPC system without training provides a very inefficient use of those systems. And one of our goals is to try to run our system at 98, 99% operation at all times, so we don't waste a cent of energy. By the way, our system is powered by 100% renewable energy as well.
Next, I'd like to invite Shinji Shimojo. He's director for Cyber Media Center. He recently won an award, Supercomputing Asia for Network Award. Shinji Shimojo. Well, it's basically for his dedication, not only to network, but to HPC as well.
Thank you, Francis, for the great introductions. Yeah. So, my name is Shinji Shimojo. I'm same position as Francis. I'm not the supercomputing guy, but even I am a director of the Cyber Media Center. That's not the center. I'm more familiar network, so I don't need to present some. So this is some kind of advertisement from Saturday. That's one of the supercomputing guys and our center. We have in Osaka University we have a campus, and the Line one is our data centers. It's dedicated for only for supercomputers. We are responsible for development and operation of the mesh infrastructure, including this. This is our cyber infrastructures, and we have an integration of the two supercomputers, which I will is the screen and the bus, and it's also connected to the Onion, which is data infrastructures we are developing, and also that it's connected to the cloud. So if we overloaded, job goes to the cloud as well, and it's connected to the high performance network, which is provided by the SciNet, which is national network infrastructure. So they are accessible from the outside. This is, I think, the supercomputers guys likes the number. So these are the numbers we have. We have many nodes. We have, even GPU, and one of the the feature we have for the screen is we have some vector nodes, vector-oriented supercomputers as well. And we name it, nowadays a supercomputer is named by something good or something special. What's special for us, Osaka, is octopus and the squid. We like both very much. So if you come to Osaka, you can enjoy those two delicious foods. And so we name our supercomputer based on those squid and octopus. If you like, you have I have only 10 copies. Sorry for that, but we have a very nice souvenir for squid. So if you like, please take that. And as I said, I'm not special for the computers, but I'm lucky heard and talk about the collaboration, especially for the Asia. One thing is SCI, the keynote of the SCI. My friends, Santosh Matsuka, who is director of the computer, talked a very nice talk, very nice keynote. I think, is it available? No, if you miss it, it's very good. So I borrow him from some slides, so I will pick something. And also as Joe said, that there's a collaboration from Europe and ASEAN. So ASEAN collaboration. We have a workshop in Japan, EU collaboration. So I borrow some slides that presentation. So one thing I borrowed from Matsuoka-san, he's the head of the Fugaku computers. And as you may know, Fugaku is a top computer in the world right now. And we make the Fugaku as from the Mount Fuji, it's the very highest. Maybe it's lower than Himalaya Everest, but our highest mountain in Japan. We name it from this mountain. And the other thing I borrowed from is access to HPCI. I will talk later, but you can access from the outside to Japanese supercomputers, Japanese cluster of supercomputers. So I would like to express how. And so we have around 8 national supercomputers around. And we form, in conjunction with Fugaku, we form a group of consortium of supercomputers, which is called HPCI, National High Performance Computing Infrastructure. And it could be accessed the whole academia and even the industry as well, inside Japan, also the outside Japan. So it's open to everyone for the research. Those are the top supercomputers in from Hokkaido, Tohoku, Tsukuba, Tokyo, Tokyo Institute of Technology, Nagoya, Kyoto, Osaka, Kyushu, JAMSEC. Yes, those are the collaborate together to have a single accessible infrastructure. So you can access in one ID, which is called HPC ID, to every computer. And we accept the application from the outside. The application mechanism is like that. This is the framework for the HPCI application. So every year or maybe more than couple of times in a year, we accept the applications, which is applicable for usage of the Fugaku as well as those tier one system. Tier one system is other than Fugaku, we have many supercomputers in the academia, so that it is included in the HPCI. And if those applications is accepted, you can use those resources free of charge. But first, I think you have to do both. This is something good. And all those are supported by the Ministry of Education and managed by the list, which is one of the administration office of weekend. So this is project categories of Fugaku. We have a general access and industrial access and a general access for junior, even for the junior research. And you may know this is a node hour, which is allocated for those purposes. So I think you can choose your categories, and there's a periodic call in twice per year. And some call open for throughout the year, like a small scale trial or trialing. So these are the open to the public. And this is a project category other than Fugaku. So it's some other computer resources, which is the same categories in this general use. And also there's an industrial trial, industrial project with added service. So I think this is, if you want, for the industry, if you want to disclose your result, you have to pay some amount of doing this. This is the condition. So if industry can open their research results, you can use it as a tool. And Nepal is the example. This is actually open worldwide. So this is access of the. I choose Nepal. So any Nepal researchers, including so they can access to the HPA system, including Fugaku and the second layer resources is other than Fugaku system. And there's no limitation for application proposal outside Japan. You have to be careful about the those regulation about the export control. That is one thing you may worry about, but it's not so difficult for you to apply. So for general access or junior research access, sorry, this is mainly European, but even for ASEAN people can apply to those. And you may know Fugaku is the world's largest and the fastest computer drivers, and they are using the ARM machines, and this is some entire service units provided for Fugaku. And they are very successful for the core design. So very diverse applications can be supported in high performance in the Fugaku range. And this is another actually collaboration framework, which is called JHPC. You can use this. This is the Japan Usage Research Center for interdisciplinary large-scale information infrastructure. This is also the collaboration on the National Computing Center in Japan, and it's also application is open for the public. And they have some special international collaboration program so that you may apply, but it's joined with Japanese researchers. So if you find some collaborator in Japan, you can apply to this joint international program. So you have to check that. This is also do once a year. I think this is already Francis told that this collaboration. So ESTA and NSCC and DKN has already collaborated. So those kind of things could be applied or extend to other countries as well, I believe. And so for the Singapore, you can access to all the HPCI resources, and Singapore can be collaborate, and they have some trial program of ASEAN HPC standard with help of Singapore ways. And I think good things about there's a discussion about how network can be collaborate with the supercomputer, but you may see, this is our, underlying infrastructure for using those supercomputers. So we are connected in APAN. We are connected those infrastructure. So, I put the network especially you can access in, resources scattered around those infrastructure. And as I said, there is ongoing example for Fugaku in ASEAN countries. So there are already success cases, including the Malaysia, Thailand, Philippines, Indonesia. So those projects are already going with the help of Singapore and many people. And Francis is very much good at the data sharing and the data movement. Thanks to Francis for data moving challenge here. So that we improving the data movement around those Asian countries. So that this could help the supercomputing as well, because currently many supercomputers has to treat big data to analyze. So you have to move your data to the supercomputing side. And this is possible in the APAN community. But I think you need some special help for the network. It's not so easy. so I think you have to consult those guys like Francis to achieve those things. And this is one example which the ASEAN countries can do. It's Amazon told us that in Indonesia, some collaboration with Japanese government and the Indonesian government, they have a collaboration to use supercomputer to improve their industry as well. And also it's dedicated to the green society as well. So as a collaboration of those, Japanese industries, academia, and also Indonesian industry and academia, it could be possible to have those kind of projects. I think this is very interesting project. So they design some filters, the structure. The simulation is using the supercomputer, so that you can design the quick filter for this process. So those kind of things are possible. And as many said that the education is important. This is already that these ASEAN collaborations we have a ASEAN supercomputer HPC school. It's already on. Okay, so this